Hello students, myself is Parminder Singh from Prab Kripa classes. Our today's topic is DBMS module 5. We have already uploaded 4 modules, and in the first module we had learnt about the difference between data and information. Then what is the meaning of database, what are the common types of database, whether a company has to stick or whether a company sticks to only one type of database. Then in the second module we had discussed the meaning of DBMS, functions of DBMS, and database servers act as the backbone of data management and delivery, and the what are the various types of database servers. In the DBMS module 3 we had learned about the benefits and limitations of DBMS and how DBMS ensures concurrent access to data and the benefits of using a DBMS over traditional file-based system. And in the module 4 we had learnt about the ACID properties in DBMS, what are the various components of DBMS, relational database model, its key concepts, what is primary key, foreign key, and composite key in DBMS. Now, in this current topic, the students will understand what are the current trends and future directions in database management system. The students will learn that cloud-based DBMS, big data and data security are the current trends, whereas the artificial intelligence, machine learning, and data virtualization and blockchain technology are the future directions in database management system. And the future of database management system is very good, and the database management system technology is changing very fast so that it can come up to the expectations of the individuals as well as the organizations, as the organizations have to deal with large amount of data and the nature of data is also changing from time to time. The students will also understand the differences between SQL and NoSQL databases. The students will also learn why some companies use a combination of both SQL and NoSQL databases to store and retrieve data. They will understand that each database, whether it is SQL or NoSQL database, each database has its own strengths. The companies use the combination of both databases so that it can take the advantages of both the strengths of the both types of databases. On one side, SQL databases have ACID properties compliance, whereas NoSQL databases are known for their flexibility. The students will also understand that the relational model ensures data integrity through various types of constraints such as integrity constraints, referential integrity, unique constraints, cascade and restrict actions, and ACID properties. You will also learn, or you will also have some knowledge about the ACID properties, for which we have already uploaded a full course. The students will also learn about the various data models to store data, which include relational data model, NoSQL data model, multi-model, hierarchical data model, network data model. The students will also learn about the various subcategories of NoSQL data models, that is object oriented, my document, in memory, or various other data models, graph data models. You will learn about the same or have an overview of the same. Now our today's topic is current trends and future directions in DBMS. If we talk about the general world, everything is changing at a very fast speed. Let it be the field of telecommunication, transportation, manufacturing, IT. Technology is changing very fast, and the DBMS is not an exception to that. DBMS, that is database management system, has come a long way since their inception in the 1960s. In the past, database management system was mainly used to store and organize data, because in the previous times the data was simple. But with the passage of time, the shape of data, that is the data types, are changing enormously. Earlier, we used to save only the data in the form of text, but now the organizations have to save the data in the form of audio files, video files, images, hashtags. That is, this data may be semi-structured or unstructured, and the data types are also changing with the passage of time. So in this scenario, when the organizations have to deal with the ever increasing size of data, and as well as the changing nature of data, that is the data types, the organizations have to adopt the latest technology in DBMS. So now the DBMS is also being increasingly used to analyze data as well as provide insights to drive decision making. That is, today in this competitive world, the organizations have to take decisions on the basis of, mostly on the basis of the data. And because the organizations have large volumes of data, the DBMS helps them in having a brief and up to the latest knowledge about the data, which helps them in taking the appropriate decisions at the relevant time. So now we will discuss some of the current trends and areas of interest in database management system. First is big data and NoSQL databases. Big data means large volumes of data. In these days, the organizations have to deal with large volumes of data. The relational databases remained popular for many years. As you know that in the case of relational database, tables are used to store data in which there are rows and columns. But with the passage of time and with the rise of social media and Internet of Things, social media means WhatsApp, Facebook, and all other things, businesses are generating and they need to handle vast amounts of unstructured or semi-structured data. As you know that with the passage of time, a large number of e-commerce sites and other organizations have come into existence, which have to deal with a large number of products. And in the case of Facebook and WhatsApp, they have to store and manage the data of their customers in the shape of reviews, comments, etc., which is semi-structured or unstructured data. So when all these types of nature of data is increasing and the nature of data is also changing from time to time, so there is need that the DBMS has to come up to the expectation of the organizations so that they can handle all these types of diverse data. As a result, NoSQL databases such as Cassandra, Redis gained popularity. they are suitable for handling large and diverse data sets. Data sets means collections of data. Next is graph databases. Graph databases are those databases in which the data is stored in the form of graphs. Graph databases are gaining popularity for data with complex relationships. These databases are particularly useful for social networks, recommendation engines, and fraud detection. Recommendation engines means if you search anything on your Amazon, then you find that on the next day or on the same day, you will be start receiving on your social media the related products. If you search about, say, a particular type of beauty cream, then these sites will start sending you the advertisements in respect of various types of beauty creams. It is only because of the recommendation engines. For example, a graph database could be used to store the routes between different cities in a transportation system, or the relationships between people on a social network. Popular graph databases include Neo, Horse, and Amazon Neptune. Next is in-memory databases. In-memory databases are gaining popularity because they respond very fastly than the traditional systems. The main reason for their fast response is that they store data in the computer's main memory, that is random access memory, instead of on disk. When the data is stored on the main memory, it results into faster processing and analysis of large data sets. So the organizations find it easier to make real-time decisions. Real-time means as soon as the data is generated or received, the organizations can take decisions. In-memory databases are used in areas such as financial trading, online gaming, where delay of fraction of a second can have significant consequences. Examples are Memcached, Hazelcast, and Aerospike. These databases are very popular in financial trading. Financial trading means in the case of stock markets, where if there is delay in taking any decision, even by a fraction of second, it may result into missing opportunities. It means that a share, if you have any interest in the share market, you might be knowing that suppose a particular share, yes, a particular share of a company is trading at, say, rupees $100, and there is a news in the market that the profits of the company have decreased by 25%. Naturally, the stock market will react accordingly, and it is expected that the share price of that company will fall accordingly. So if your system is fast, then you can immediately sell your stock, and if your system takes some time, then it will result into loss, and you will miss the opportunity to sell your stock in time. Next is multimodal databases. Multimodal databases supports multiple data models, that is relational data model, document data model, graph data model, etc. within a single database system. Multimodal databases are well suited for applications where data is diverse and does not fit neatly into a single data model. For example, a relational data model is suitable only in respect of that data which can be fitted into the shape of tables only. It is not suitable for images or semi-structured or unstructured data. So in that case, multimodal databases where the organizations have to deal with multiple types of data, multimodal databases are suitable. These databases are suitable in areas such as content management systems, product catalogs, etc. In the case of Amazon, they have to maintain the product catalogs of a large number of products. So they use multimodal databases. Some popular multimodal databases include Erango DB and MarkLogic. Next is open source DBMS. This is a type of DBMS which is available for free. Most of the database management system which are available in the market and which are of having latest technology built in them, they are of course paid. But there are some other database management systems which are available for free and can be modified by users. Open source DBMS is a popular choice for organizations that want to save money on licensing costs and have more control over their database environment. Some of the popular open source DBMS are MongoDB, MySQL, PostgreSQL, and MariaDB. Next current trend in database management system is single database versus multi-database systems. Multi-database systems are becoming very popular these days between the in the organizations because the organizations have to deal with large and different types of data. A multi-database system can consist of different types of databases such as relational NoSQL databases. This way, the company can select the most suitable database technology for each data type. This helps the organizations to perform better because they can use the technology or the database which is well suited for the particular type of data, and it also lets them not being stuck with one technology or vendor. Now the question arises whether the organization should use single database or multi database systems. The choice of whether to use a multi database system or multi database system or single database system, it depends on the specific requirements of the organization. Now another current trend which is gaining popularity these days is cloud based DBMS. Cloud based DBMS means the DBMS pertains to the third party service providers such as Amazon, Microsoft, Oracle. The servers do not belong to the organization, but they avail the services of third party companies who provide the services of DBMS for charges. This trend is gaining popularity because of its scalability. Scalability means if an organization wants that its data it is growing very fast and it will have to, as the data is increasing, so they will have to store the data For that purpose, more servers may be required. In that case, cloud DBMS is a suitable option, because in that case the organization itself will not be required to purchase hardware, software and pay for its maintenance. All these types of activities, that such as hardware, software and maintenance, will be done by the third party service provider, because they will maintain, purchase or do all the things. You are only to avail the services of servers. It is flexible, that is, if with the passage of time your company is does not require more servers, because your requirement of data has decreased, because your company is not growing at fast, so you want to reduce the number of servers you are availing the services of. So in that case you can reduce the number of servers on which you are storing your data, and it is cost efficient. Cloud based DBMS is cost efficient in the manner that you have not to incur the expenditure on the purchase of hardware, software and its maintenance, because it is not easy for each and every organization to purchase hardware and software outrightly. It is very convenient for many organizations to avail the cloud-based services of cloud-based DBMS. It is a system that is hosted and managed by cloud service providers such as AWS, Azure, Google Cloud, Microsoft. Organizations do not need to make significant investments in hardware and software and worry about their maintenance, and they can access their data in a cloud environment from anywhere at any time with an internet connection. It is also to be remembered that you have not to think where the server is located, where the Google or Amazon is having their servers. You can avail the services through internet at any time, 24/7. But only you will have to pay the relevant fees or the charges which they may be charging on the basis of the type of services you avail. Next is, focus on data security has increased. With the passage of time, we are storing our personal as well as our confidential data on mobile phones, computers, and the organizations are storing the data in large servers, which may be on-site servers or off-site servers, that is cloud-based servers. At the same time, when every organization is having a large amount of data and many of the data falls in the category of very confidential data, the cyber criminals are also very active, and they are always busy in developing various types of malware so that they can unauthorizedly access data and sell them in the black market, or they can exploit the organizations in the form of ransomware attack. So when the cyber criminals are also active, it has all the more important for the organizations to take every possible step to protect their data. So the emphasis on data security has increased, and it is one of the biggest headache of the organizations. As the organizations are increasingly concerned about the protection of their data, data security is a top priority for DBMS. It may be added that, though it may be out of context, still I will want to say that we as an ordinary individual think that we are having only small data in our computers, and the cyber criminals do not have any interest in our small people. They will be interested in bigger organizations such as Bank of America or bigger organizations, so that they can they can attack their computers of the bigger organizations and get ransom from them to release their data. It is not so. The cyber criminals also know that you as an ordinary individuals mostly do not take necessary steps to protect their data. Most of us are having only free antivirus installed in our computers. Please do not do so. Take the best steps you can take to protect your data even as an individual. Though we are discussing at the larger level at the level of organizations, but if as an individual we are unable to protect our data, then the reading of all this database management system or large other articles on information technology will not serve any purpose. If we should take the best possible steps we can take to protect our data, for that purpose we have already uploaded our courses on antivirus, cybersecurity, computer virus. You can also go through the same. Now we will come to the main point. High profile breaches like LinkedIn breach in June 2021 and the sale of millions of Facebook user records in October 2021 draw attention to the fact that the threat to data security continues to exist and is a serious concern. It is not that the organizations which we have discussed, LinkedIn, Facebook, and the organizations do not take necessary steps to protect their data. Even after that, the cyber criminals are able to unauthorizedly access the data which is available with them in their servers. If you go through the media reports or the newspaper reports daily, you will always find that the cyber criminals are able to unauthorizedly access, or there is some sort of data breach in the case of some particular organization, and this trend is continuing. So no organization should think that it is totally protected. So we as an individual as well as an organizations should take all possible steps. The list of data breaches is endless. DBMS vendors means those companies who are developing, selling, and providing the services in respect of the DBMS are constantly developing new security features to protect data from unauthorized access, tampering, and destruction. Database administrators must work with IT security team to identify and rectify internal weaknesses that could potentially expose data to risk. Though DBMS vendors are always busy to take new security features so that our data is protected, we at the individual level should also be aware of the cybersecurity best practices. Next is multi-cloud DBMS. Earlier we have learnt about cloud DBMS. That is, we may avail the services of one particular cloud-based service provider. But it may be possible that at one particular time, the services of one particular cloud service provider, say Google, is not available because there may be some floods in the relevant area where the servers that organization are there, or there may be fire in that organization who is providing a service, that or some sort of other problems may be there, which may result that we may be unable to access our data. though the duration of such type of problems is very less, because these organizations which are multinational incur a huge expenditure on providing the best services to their clients, but such scenarios are possible. So in that case, the organizations are also now preferring that instead of availing the services of one particular cloud-based DBMS service provider, they should use the services of many cloud service providers, so that in the event of any unforeseen contingency, their services are not affected. They are able to access data, and they can store data, access data, and provide better services and continue services to their clients. Let us read what is written. Multi-cloud refers to the strategy of using services from multi-cloud providers such as AWS, Amazon Web Service, Azure, Google Cloud simultaneously. That is, at the same time, we are using the services of many cloud service providers. Organizations adopt multi-cloud to avoid vendor lock-in. Vendor lock-in is a situation where we are unable to change the vendor. If we are suppose using the services of say Google only, and vendor lock-in, that situation means the situation where we are unable to change our vendor due to various reasons. It may be the reason of technology or the skills required to run that technology, etc. So the organizations are using multi-cloud to avoid vendor lock-in and take advantage of each provider's strengths and ensure continuity of operations in case one provider experiences downtime or issues such as natural disasters, cyber attacks, and hardware failures. If we become heavily dependent on one cloud service provider, it may go against us in future. In the case of natural disasters or cyber attacks, if a cyber attack occurs, say on the Google service provider who is providing you service, and you are availing the services of that particular organization only, then it is quite possible that all of your data may be leaked. But if you are using the services of say different types of cloud service providers and your data is scattered, and your data will be leaked, or the cyber criminals will have access to only a few percentage of the total data. So it is the depends on various factors whether we should use the services of single cloud service provider or multi-cloud service providers. Next trend is automated DBMS. Automated DBMS is both a current and future trend in DBMS. Now many organizations are already using the automated DBMS so that they can improve their efficiency, security, and the performance of their database. But as already told, that the volume of data with each and every organization is increasing, and the complexity of data, nature of the data is also changing with the passage of time. So the need for automated database management system is growing at a very fast speed. Automated DBMS can automatically back up data on regular basis. It can also automatically audit the database for security weaknesses so that they can be fixed before they are exploited. It is also the benefit of automated DBMS that it can automatically tune the database for best performance. So when DBMS does all these steps automatically, in the case of automated DBMS, it frees the DBS. DBS means database administrators to focus on other tasks, because the database administrator is responsible for the proper functioning of the DBMS. When the automated DBMS does many works itself, so the database administrator can focus on other areas or other tasks which for which he may be responsible. Next, we will now discuss on future directions at DBMS. That is, what is the likely scenario with respect to database management system. As the technology is changing very fast, we can safely say that database management system has a very bright future. The capabilities of database management systems are expanding, making it easier for businesses to gather, analyze, and utilize data. Now we will discuss some of the trends that are shaping the future of DBMS. First point is shifting to cloud-based DBMS. Earlier, the organizations were having on-site servers and they were spending from their own pocket to purchase hardware, software, and other necessary infrastructure so that they may have data stored in the DBMS. But now, with the passage of time, as the volume of data is increasing and various types of data have to be dealt with by the organizations are moving towards cloud-based DBMS, which allows them for greater flexibility, scalability, cost effectiveness. Next is scaling up DBMS capabilities. Database management systems are being built to handle increasingly large amounts of data in real time. That is, the capacity of the DBMS to handle the data as and when received or as and when generated is being increased, so that the organizations can take decisions in real time, that is on the spot and immediate as far as possible. DBMS needs to gear up to manage and process vast data sets. Data sets means collections of data, vast collections of data. As organizations rely on data to make informed decisions and competitive. So, as the data is increasing and the DBMS technology is being geared up so that they can help the organizations to take timely decisions in this competitive world, because the delay in taking a decision even by a fraction of a second can result into missing opportunities, as already discussed, in the form of financial trading, online gaming, etc. We take the example of Amazon, which is a multinational company which has to store data in respect of every search and purchase made by the customers, and they have to also store data about the product availability. They also store user generated reviews, ratings, and information about the customers made by the customers. So the DBMS has to be geared up, or the DBMS technology has to be changed so that they can take or they can store and analyze various types of data, and the user is in a position to assess the data as and when required very quickly. Privacy and security. As data breaches have become more common, DBMS are working to provide better privacy and security measures to their users. Now the latest trend or the future trend is, which is also an important, that is blockchain technology. It is a promising innovation that has the potential to revolutionize the way we store and manage data. Now, what is the meaning of blockchain? It is a distributed ledger technology that is used to record transactions in a secure and tamper-proof manner. It is being considered as a potential solution for data security and privacy in DBMS. Blockchain technology can be very useful in the fields such as financial systems or medical systems where high data security is essential. Now, another future trend is data virtualization. It is a future trend in DBMS. It is a technology or data integration approach that allows the organizations to assess and query data from multiple sources and provides a single unified view of data. This can be very useful for organizations that store data across multiple systems such as on-premises databases, cloud databases, and SaaS applications. Next is data governance. Data governance means set of processes, policies, standards, and practices which ensure that data is managed in a consistent and secure manner. It is becoming increasingly important as organizations collect and store more data. The organizations need to focus more on protecting sensitive data from unauthorized access, breaches, and data leaks. Some data privacy regulations such as GDPR, which pertains to the European Union, and CCPA, which is the California Consumer Protection Act, are already there. Any and many more may come in force to ensure that personal and sensitive information is handled in compliance with relevant laws. In European Union, the organizations have to take into consideration GDPR. In California, the organizations have to take into consideration the California Consumer Protection Act, where the organizations which deal with the data of consumers, they have to follow certain rules and guidelines. That is, the customers may opt that their data will not be sold by the third party for any purpose, or such other guidelines are there which have to be followed by the organizations strictly. Otherwise, they have to face heavy penalties. And such type of data security laws or rules and regulations are already in force at various places, and many more are expected to come into existence with the passage of time, as data security is now a very big concern for the organizations. Next is Internet of Things. As more and more devices are connected to the internet, DBMS will need to adapt to handle vast amounts of data generated by these devices. You have seen the traffic signals, cameras are installed, CCTVs are installed. Such type of CCTVs may be installed at many places in the whole of the city. So it is the database management system which takes care of to store and manage the data, and which helps in the retrieval of the data of all these devices. Artificial intelligence and machine learning. DBMS will incorporate artificial and intelligence and machine learning to automate tasks such as data management, data analysis, and identify patterns in data that may indicate fraud. Otherwise, it may be very difficult or impossible for the organizations to go through large volumes of data to arrive at particular important information which may be helpful for them to arrive to take the decision, or the organizations may be finding it very difficult to go through large volume of data to find out whether there is any fraud going on in any part of the organization. In all these spheres, artificial intelligence and machine learning is going to help the organizations in a very big way. DBMS are constantly evolving. Evolving means the technologies of DBMS is changing. They are changing itself. That is, the database management system is changing itself very fast so that it can come up to the expectations of the individuals as well as the organizations with the passage of time. Cloud-based systems, big data, and data security are current trends, while in Internet of Things, artificial intelligence, and blockchain are future predictions for database management systems. The capabilities of DBMS are expanding, and it is helping the organizations to gather, analyze, and utilize data. Overall, the future of DBMS is very bright, as the businesses are increasingly relying on data driven decision making, because the data is very large and they want only the important information on the basis of which they can take decision, and the DBMS surely helps them in data analysis. With the right DBMS in place, businesses can valuable insights that can help them streamline processes, improve products and services, and drive growth. That is, DBMS is providing a very useful services to the organizations, which helps them in taking timely decisions so that they can make so that they can improve their services, improve their products, and go on the path of progress. Now our topic is difference between SQL and NoSQL databases. We have already uploaded a course, DBMS Module 1, in which we have already discussed in detail the common types of databases. Here we will concentrate on only two types of databases, SQL and NoSQL databases. Now the first difference on which we will be discussing is the data model. SQL databases primarily use relational data model. What is the relational data model? Relational data model is a model which makes use of tables to store data. In the table, there are rows and columns in which the data is stored. Now, in the case of NoSQL databases, they use various data models such as documents, key value, common family, graph, etc. Now the next point is schema. SQL databases have a predefined schema, which means that the structure of the database of the data in the database is fixed and well defined in advance. This makes it easy to query the data and ensure that the data is consistent. On the other hand, in the case of NoSQL databases, these databases are known for their flexibility and schema-less or schema-flexible approach. NoSQL databases are better suited for scenarios where data structures are less predictable or frequently evolving. Frequently evolving means the nature of the data changes. Now, another point is query language, structured query language. SQL databases use the structured query language, that is SQL as their query language. SQL is a powerful standardized language for querying and manipulating data in relational databases. On the other hand, in the case of NoSQL databases, they use different query languages depending on the data model. We will discuss about various types of data models in the coming courses. For example, key value databases usually do not use complex query languages for data retrieval. These databases retrieve and store data quickly using keys. Another example is each document database may have its own query language. MongoDB, being a specific document database, uses its own query language MQL. Now the fourth point is scalability. SQL databases are typically designed for vertical scaling, that is scaling up, which means that the performance of the database can be improved by increasing server resources like CPU, memory, and storage or other resources. You have seen the trees which grow in this way, that is upward. So this is known as vertical scaling. Suppose there is a house, there is a vacant plot, and you have built a room on it which can accommodate say 2 persons. With the passage of time, the size of the family increases and you have two options before you. Either you take or build a separate house, or you can construct another room on it. On the same plot, you can construct another room. It is in the same way that in the case of SQL, there is vertical scaling. That is, we do not add more servers to meet up the expectations. That is, if the organization feels that the volume of data is increasing, it needs to make use of more servers or upgrade the present server. In this case of SQL, vertical scaling is used. That is, the server is upgraded, its memory, its storage capacity, or CPU is increased, and though scaling out, that is adding more resources, can be possible in the case of SQL, but adding more servers is complex and expensive for SQL databases. So in the case of SQL, it is preferred that scaling, a vertical scaling, that is scaling up technique is used. That is, we increase CPU, RAM, storage and other resources so that we can handle the increasing data volume. Whereas in the case of NoSQL databases, they are designed for horizontal scalability. Horizontal means in this way, that is increasing the number of servers so that the increase in that data may be properly handled, which means that the performance of the database can be improved by adding more nodes or servers to the database. NoSQL databases can continue to function even if one or more nodes fail. That is, suppose if there are 4 servers working, even if one server fails, other servers will continue to function, and overall the functioning of the organization will not be affected. You can you can scale your NoSQL databases up or down as needed. That is, if the organization feels that the volume of data has which it has to deal with has decreased. Suppose the organization's business is not growing at a very fast speed, and the organization thinks that it need not to have the facility of as much servers as it is utilizing as on day. So it may decide to reduce the number of servers it is using. Adding more servers can accommodate increased traffic or data growth, and you can remove nodes when demand decreases. That is, when the demand of, of, of the servers in respect of the service you want to provide decreases, that is, your need for data storage decreases, then automatically you can decrease the number of services. This is possible in case of NoSQL databases. Next point is use cases. SQL databases are best suited for structured data. We give the examples of structured data. These are customer records, product inventory, and financial transactions. Whereas in the case of NoSQL databases, they are best suited for semi-structured or unstructured data. And the examples of the same are social media posts, reviews, hashtags, audio video files. Another point is development speed. The development speed of SQL is slower due to schema constraints. What is the meaning of development speed? Development speed means the time and effort required to maintain and build a database system. That is, it takes a lot of time and effort to build a SQL database system in the case of SQL. Whereas in the case of NoSQL, development speed is faster due to schema flexibility and dynamic data. Next point is ACID compliance. We have already discussed in detail about the ACID properties in DBMS, which is atomicity, consistency, isolation. Now, SQL databases are traditionally designed to follow ACID properties strictly. NoSQL databases vary in their degree of adherence to ACID properties. Some NoSQL databases, especially new SQL databases, provide strong ACID guarantees. That is, they strictly follow the ACID properties in DBMS. D stands for durability, while others prioritize performance and scalability over strict ACID compliance. Now, another point is atomicity. SQL databases guarantee that transactions are atomic. That is, the transactions either are fully completed or fully rolled back in case of failure. The failure may be power failure, internet failure, or any other. There are no partial transactions. In the case of NoSQL databases, atomicity depends on the specific NoSQL database, the atomicity of the transactions may be more relaxed. Next point is consistency. SQL databases ensure data consistency, enforcing rules and constraints. We will also discuss in detail how the relational model ensures data integrity through constraints and rules. On the other hand, NoSQL databases, the level of consistency enforcement varies among NoSQL databases. Some NoSQL databases offer strong consistency, while some other NoSQL databases provide eventual consistency, which allows for temporary consistencies that are resolved over time. Next point is isolation. SQL databases provide isolation between concurrent transactions. This means that concurrent transactions do not interfere with each other, and each transaction appears to run in isolation from others. Isolation levels in NoSQL databases can differ. Some databases offer strong isolation, while some other NoSQL databases offer weaker forms of isolation. Next point is durability. SQL databases guarantee the durability of committed transactions. Committed transactions are those transactions which have been saved in the database. Once a transaction is committed, its changes are permanently stored and will survive system failure. Durability guarantees are typically maintained in NoSQL databases. Once data is committed, it is durably stored. However, in certain situations, some NoSQL databases allow users to reduce the level of durability in exchange for improved system performance. Next point is data structure. SQL databases store data in tables which is made up of rows and columns. Each table in a row represents a single record, and each column contains a single piece of data about that record. You have already learned that in the case of a relational model, there are rows, these are the columns, and we may here take the example of employees. In that case, there may be column heading employee name, employee ID, then employee contact number, and much more. This is row and this is the column. This is what is written in this row is known as the record, and what is written in the columns, it is known as a single piece of data about that record. On the other hand, NoSQL databases store data in different ways depending on the data model they use. For example, key value databases store data as pairs of keys and associated values. Document databases store data as documents, and graph databases store data in the form of graph-like structure. Now we will see the examples of SQL databases. The examples of SQL databases are Oracle database, MySQL, Microsoft SQL Server. In the case of NoSQL databases, the examples are MongoDB, Cassandra, Redis, Amazon, DynamoDB. Now we will conclude the difference between between SQL and NoSQL databases. The choice between SQL and NoSQL databases depends on the specific requirements of the application, that is, data structure, scalability needs, query complexity, or performance goals. Many organizations use both SQL and NoSQL databases together. Why? To handle the different types of data storage and retrieval requirements. For example, an organization might use a SQL databases to store customer data, and the same organization may also use the other database, that is NoSQL database, to store social media data. We may take the example of Amazon. It may use both types of DBMS, SQL to store the customer information or product catalogs, and NoSQL database to store social media data, that is the audio video files, reviews by the customers. If the organizations use both type of databases, then it allows the organizations to get the best of the two worlds. To get the best of the two worlds means to get the benefits of both types of databases. And what are those benefits? The flexibility and scalability of NoSQL databases, and the performance and ACID guarantees of SQL databases. That is, the organization can take the benefits of strengths of both these types of databases if they use both of these databases. Now the topic before us is, how does the relational model handle data integrity and enforce constraints? The relational model is the basis of most modern relational database management systems. Relational model provides mechanisms to handle data integrity and enforce constraints. Here are some key features of the relational model related to data integrity and constraints. We will discuss about the same with the help of these subheadings. First is entity integrity, referential integrity, constraints, and ACID properties. First is entity integrity. The relational model ensures entity integrity through primary keys. The primary key constraint ensures that no two rows in a table can have the same key values. Here in this case, this is the primary key, customer ID. Now, the primary key constraint ensures that no two customers out of the whole customers have the same values in the customer ID. That is, if the one customer is having this ID C12345, then in the whole of the table of customers, no other customer should have this customer ID. For example, in the customers table, customer ID is the primary key and it ensures entity integrity. Each customer is uniquely identified by their customer ID, and no two customers can have the same customer ID. The same applies to the employees table. That is, no two employees can have the same IDs. Here in the case of customer table, customer is the entity. In the case of employees table, employee is the entity, and so on. Now the next point is referential integrity. It is maintained through foreign keys. A foreign key is a field in one table that refers to the primary key of another table. We have already discussed in detail about the relational model, primary key, foreign key, composite key in detail. You can see the same. foreign key establishes a relationship between the two tables. We will understand this concept with the help of an example. Suppose you are having two tables. One is customers table, another is orders table. In the orders table, here you will see the customer's ID. It is the foreign key which is having the relation with another table, that is the customer's table. Here customer ID is also appearing. Here it is the primary key. Now this customer ID which is appearing in the orders table refers to the customer ID in the customers table. This foreign key has established a relationship between two tables. Now each customer ID in the customers table must refer to a valid customer ID in the customers table, ensuring that referential integrity is maintained. This step ensures that we cannot insert an invalid customer ID. That is, if suppose we want to insert customer ID which starts with A 1 2 3 4 5, but all our customer IDs are which are stored in the database start with C. So the system will not allow you to feed this customer ID in the orders table. This step ensures that you cannot insert an order record with a non-existent or invalid customer ID, preserving the referential integrity of the database. That is, what is being referred to in this order table, whatever mention has been made about the customer ID, it must refer to some valid customer ID in the customer table. Now the other point is constraints. The relational model supports various types of constraints to enforce data integrity rules. We will now discuss some commonly used constraints. First is unique constraint. Unique constraint ensures that a column or a combination of columns have unique values across the table. Here we take the example of email column and phone number. We can apply unique constraint on these two columns to ensure that no two customers or no two employees have the same email ID or phone number. This safeguard or constraint ensures that specific columns contain only unique values, preventing data duplication. For example, if the person is feeding data on the system and through an oversight he feeds the same email ID in this field also, the system will not allow the same, and in this way database integrity is maintained, that is data is proper. It will ensure, unique constraint will ensure that the data is proper throughout the database. Next point is check constraint. Check constraint defines a condition that must be satisfied for the data in a column or columns. It prevents insertion of values that do not meet the specified conditions. We will now understand the same with the help of an example. Suppose you have orders table with you. Now this table contains information about customers' orders which are placed by the customer from time to time. You want to ensure that the order status, this column, contains certain predefined values such as pending, processing, shipped or delivered. That is, the customer make the orders and the said orders are fed in the system, and you want that here the order status should have predefined values. That is, we cannot feed ourselves what we want to say. There will the options will be given such as the order is pending, order is shipped, order is delivered, or under processing. You can use a check constraint to enforce this rule. Any attempt to insert a value in the order status outside of the specified list will result in a constraint violation error. That is, if you try to insert any other data outside these four: pending, processing, shipped, or delivered, though you may change what type of values you want to insert at the level of database designing. Here we are taking the example of that we are having only four options which are there in the which we have designed in the system. So if we try to insert any other value in the order status, the system will not allow us to do the same and it will show constraint violation error, thus maintaining the integrity of the database and ensuring that only valid order statuses are recorded. That is, whatever we have selected at the database design level, only as per that the database shows what is the present position of the particular order. Next point is note null constraint. This constraint ensures that a column cannot have a null value. Null value means missing value. That is, it ensures that these types of columns which are given here do not have missing value. That is, it is not possible that we leave any of these values as blank. When registering on a website, we have to provide information such as email, mobile number, and password. Whenever you go to website, suppose you want to register yourself on Amazon website, the website will ask you what is your name, what is your email address, what is your mobile number. These are the basic informations, and in that case the website will have a not null constraint on these types of information. That is, you cannot leave your name blank, you cannot skip the email address or mobile number, you must have some password when you want to log in. Web developer normally applies a not null constraint. That is, web developer will see that you surely fill these columns to the fields like name, email address, mobile number, password. That is, must fill the same to ensure that these fields cannot be left empty during the registration process, so that the website may communicate with you at any stage if the need arises. This helps in maintaining data integrity and prevents incomplete user records. It only enforces the presence of data and not its correctness. It is an important point. Suppose while filling the email address, suppose abc.com is a valid name, just like gmail.com, it is valid. Suppose in case of Gmail, you mention in the record @smail.com, it may or may not be possible that any such email address exists, that is @smail.com. Gmail is valid, but the system will not check whether any service is there in the name of smail.com, whether there is any company which provides this service of email facility. The system will not check the same. Here the constraint is only related with that, with this aspect, that the information should not be left blank. It is quite possible that you may mention your this name as wrong. In the place of Suhail, you write Suhil, Suhil, whereas your complete name is Suhail. The system will not check all this. It is only concerned with the concept that you fill some information here. Next point is default constraint. This constraint specifies a default value for a column if no value is provided during insertion. Suppose a new employee has joined your organization and you are fill the data in respect of the same in your system. Either you fill the same date of joining yourself, or the system will automatically take it as the current date. It is quite possible that a person has joined 3 days ago. You may feel the same. But if you do not feel the same, the default constraint will automatically take the date as the current date. Now read what is written. For example, if a new employee has joined your organization and you do not explicitly specify the date of his joining, then the system will automatically use the current date as the default value as the date of his joining. The default constraint provides flexibility while ensuring that date of joining is available for every employee, even if it is not explicitly provided. That is, this field is available for every employee, that the date of joining must be there in respect of each and every employee. Now, the next point is cascade and restrict actions. These cascade and restrict actions define how changes to reference rows in a table, usually the parent table, affect related rows in another table, usually the child table, through foreign key relationships. It means that suppose there are two tables, one is customer table, another is order table. Customer table where customer ID is given having primary key is the parent table, and the customer table where there is foreign key is the child table. And if you make any change in the first table, that is the parent table, customer table, then the effect of the same should be there in the order table, that is the child table. Now we will discuss the same in detail. First is cascade action. Cascade action in a relational database is like a domino effect. You might have seen that if an international bank which is having branches across the globe falls means building, not building falls. If it fails in the international market, that is its shares plunge due to any reason in the share market, then it has a domino effect. That is, the whole of the share market in the world collapses on that day. It is the domino effect. That is, there is the resultant effect of the same on the whole of the world. In the same way, it happens in relational database. It means that when you make a change, for example, delete to a particular piece of data in a table, those changes automatically affect and are applied to the related rows in another table through a predefined relationship. That is, whenever you delete, suppose customer ID in the customer table, then it will have its effect on the orders table, that is the related rows in another table through predefined relationship. That is, the system is given instructions or what type of effect should be there if we delete something in the parent table, what type of effect it will have on the child tables. It is already decided in advance at the level of database designing. Now we will understand the same with the help of an example. The authors table, this is the authors table, has a foreign key reference in the books ID. Here it is the foreign key. This is the primary key. Here it is the foreign key. It is having relationship with this author ID in the authors table. When you perform a delete operation in this table, that is, suppose you want to delete this author, J.K. Rowling, the cascade action automatically propagates those changes to the related rows in the child table. How it happens? If you decide to read the JK Rowling from the authors table, the cascade action will automatically delete related rows in the books table, ensuring data consistency. That is, if you want to delete the author's name from the parent table, it will have its effect on the other tables which are related to it. In this case, this author is having a book in its name in the books table, which is this one, Harry Potter and the Chamber of Secrets. Now, if you delete this author, then the cascade action will ensure that this book is also deleted from here. And what will be the resultant action after the cascade action? Author is deleted. In the same way, this book is also deleted, and the new book table will here appear in this way. You can see that here the number of authors were 3. First was deleted, and its book which is here at number 1 is also deleted, and here only 2 authors are there and only their relevant books are appearing. Now the another is restrict action. When you perform an update or delete operation on a row in a parent table, we take the first example that here we want to delete the name of JK Rowling. The restrict action prevents the operation if there are related rows in the child table. You will not be able to delete this row if there is a related book in its name in the books table. Here we take the example that we are deleting the name of JK Rowling from author's ID, but there are books which are available in the books table. The restrict action will block the deletion of JK Rowling from the author's table until all related books are either deleted or association is deleted. That is, either the relationship between this author and the books table will have to be removed. Relationship should not be exist in the system, or firstly we will have to remove the books from the books table. Only after that the system will allow the deletion of the author's name. Firstly, we will have to delete the relationship existing between the books and the author, or we will have to delete the books which are existing in the name of the particular author which we want to delete. Here it is important to note that restrict action takes the first place and the cascade action takes the second place. That is, if restrict action has been allowed in the system, then restrict action will take precedence over the cascade action. When a restrict action is in place for the foreign key relationship between the authors and books table, you cannot perform a cascade action to automatically delete related books when you attempt to delete an author. In the cascade action, we had learnt that if we delete the author ID, the books which are to his credit in the books table will automatically stand deleted. But if the restrict action is in place, we cannot do the same. The system will allow the same. The restrict action takes precedence and restricts the deletion of author to maintain data integrity. You would need to first delete the associated books manually. That is, here you will have to delete this book manually, or you would need to remove the association between the author and their books. Only after that the system will allow you to delete the name of the author. If there is an author which is existing in the author's table, but it is not having any book to his credit in the books table, you can delete it altogether. There will be no problem if even if there is a restriction in place, because there is no book to his credit, and so the system will allow you to delete his name from the author ID, because there will be no book in the books table which will be without the which will be having the author ID which is not existing in the authors table. These cascade and strict actions help maintain the referential integrity of the database by automatically updating related records or preventing actions that would leave the database in the inconsistent state. That it means that if the system allows you that you can read the name of the author, then what will happen? Author ID will appear in the books table, but the system will not show who is the author, because the author ID has been deleted and system allows the same, but its related books are still existing in the books table. And when you try to find out from the system itself who is the author of the particular book whose author ID is appearing, there will be no author available in the record of the database. So it will result in some form of inconsistent state. They are important tools for ensuring data accuracy and reliability in real world database systems. Now we will discuss about another properties which are known as acid properties, which are very important in DBMS. We have discussed about the same in detail in our earlier courses. The relational model also relies on acid properties to ensure data integrity. Here A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. These properties, that is these four properties, ensure that the database transactions are processed reliably and maintain data integrity. Atomicity means that a transaction is either all completed or not completed at all. This prevents data from being partially updated or deleted. Next point is consistency. Consistency ensures that the database transitions from one valid state to another. Isolation means that concurrent transactions do not interfere with each other. Durability means that once a transaction is committed, its changes are permanent. This means that the data cannot be lost or corrupted even if there is a system failure. In the relational model and relational database management system, data integrity is indeed maintained through the use of constraints and integrity rules. If you travel on a road in your car, you might have seen traffic lights or various types of traffic signs, signals, signs are there, traffic signs are there. For what purpose they are? These types of traffic signals or other types of signs which appear in to us in on the roads, they are there to ensure that there are no accidents and the general public is in a position to safely commute from one place to another. So in the same way, these types of constraints and integrity rules in the relational model ensure data integrity. These rules and guidelines are specified when designing the structure of the database, typically in the database schema. Whenever data is added, updated, or deleted in the database, the DBMS checks these rules to ensure that they are not violated. Constraints and integrity rules act as safeguards to prevent inconsistencies, inaccuracies, or rule violations. It means that whenever you add something in the relational table, the system will automatically check whether it is as per the rules which have been defined at the level of the database designing, that is already discussed, whether the customer ID should start with A, B or C, whether the same type of customer email address is already existing, or whether the same customer ID is already pairing, whether this customer ID is existing in the database. So all these types of constraints and integrity rules ensure the data integrity in the relational model. Now the topic before us is diverse data models from relational to NoSQL and beyond. There are several data models which are used to store and organize data in databases. We can categorize different types of data models into following broad categories. These broad categories are relational, NoSQL, multi-model, hierarchical, and network. NoSQL databases are then subcategorized. We will learn about the same onward. First is relational data model. Relational data model is the most popular data model. In this data model, data is organized in tables, and each table consists of rows and columns to represent entities and their attributes. Here the attributes are shown, and here the entities are shown. SQL, that is structured query language, is used to query and manipulate data. The relational data model is used in various domains including business, finance, healthcare, and more due to its simplicity, data integrity features, and query capabilities. The relational data model is the foundation of many popular database management systems such as MySQL, PostgreSQL, Oracle database. Next is NoSQL data model. NoSQL data model is flexible and schema-less approach to data storage. This data model differs from traditional data model because the traditional data model, that is the relational data model, stores structured data, whereas NoSQL data model allows for the storage of unstructured and semi-structured or structured data. Unstructured or semi-structured data can take the shape of, say, social media posts, hashtags, reviews by the customers, audio video files, etc. There are several types of NoSQL data models, each having its own strengths and use cases. The main types of NoSQL data models are as under document data model, key value data model, columnar data model, graph data model, object oriented, and time series. We will now discuss the same one by one. First is document data model. The document data model stores and manages semi-structured data in the form of documents such as JSON and XML. In the case of traditional relational databases, you must define the structure of the database of the data in advance. That is, for example, predefined tables, columns, and their data types. That is, you have to decide what will be the various tables, what each table will have, how many number of columns, what the columns will be, and what is the data types, whether you can enter age in years. Suppose there is an implied table, you will have to predefine whether the age is to be mentioned as date of birth or completed years, or what type of information can be added, whether it can be alphabets or it can be numerical, or alphabet and numerical both. You have to define each and everything in advance in the case of traditional relational database. But in the case of document data model, there is no such requirement for a rigid predefined structure called a schema. You can store data without specifying a fixed format. Each document can have its own unique set of fields and data types. MongoDB and CuffDB databases are designed to work with this model. Now the next type of NoSQL data model is key value data model. It is the simplest data model where data is stored as key value pairs. This model is fast for retrieving data. Retrieving means accessing data using unique keys. It is highly flexible and scalable, making it suitable for distributing systems and caching scenarios. Key value store such as Redis and Amazon DynamoDB are based on this model. Now the next is columnar data model. In the columnar data model, data is organized and stored in columns rather than rows. All values from one column are stored consecutively before moving to the next column. Let us understand the same with the help of an example. Suppose you have a table with the following rows of data. Here you can see this is the data. In the row based storage, which is common in traditional databases, you have seen that in the traditional databases there are rows and where the information is filled in respect of each entity. Their attributes are given. The data would be stored as in this way: Rajan 30, Canada, Sohail 26, Australia, and then Alia 32, USA. It is followed in row based data storage. But in the case of columnar storage, which is used in the columnar databases, the data would be stored as in this way. Here it will be column wise, that is Rajan, Suhail, Alia 30, 26, 32, Canada, Australia and USA. The data would be stored in this way in the columnar data model. In the row based data storage, the storage is in this way. However, in the case of columnar data model, data is stored in the column way. The key advantage of this storage approach is efficient compression and faster query performance. It is well suited for data warehousing and analytical workloads where you need to scan and analyze large amounts of data. ClickHouse is a columnar database management system which stores and manages data in columnar format. Amazon Redshift is a cloud-based data warehousing service provided by AWS, Amazon Web Services, which also uses columnar storage format to store and manage data. Now the next is graph data model, where the data is stored in the form of graph-like structure, where nodes represent the entities and edges represent the relationship or connection between the entities. This graph data model is especially suitable for representing and querying data with complex relationships. Neo4j is a popular graph database management system that uses the graph data model, and Amazon Neptune is a graph database service which is offered by Amazon Web Services. Next is object-oriented data model. It is the data model where data is organized as objects with attributes and methods. This data modeling approach is used to organize data in a manner that reflects real world entities and their interconnected relationships. Object-oriented database management systems such as DB4O and ObjectDB are based on this model. Next, time series data model. This data model is designed for handling data that is associated with timestamps. Time series databases are commonly used in the fields such as finance and IoT, etc., Internet of Things. Time series data models are commonly used by meteorological agencies for collecting and forecasting weather data. If you have seen the meteorological working, their timestamp data is used. What is that? That at the particular time, what is the atmosphere, what is the humidity level, all these measurements are made by the meteorological agencies, where the data is stored with reference to the particular timestamp. That is, what is the position at the particular time. The same is true in respect of the stock markets, where the what is the price of the particular stock at the particular time, where that is what is here. In the case of stock markets, time series data models are used, and in the case of meteorological agencies, they are also using the time series data models, because there the data has to be represented or stored with reference to the timestamps so that the appropriate decisions can be made. These agencies rely, that is the meteorological agencies rely on timestamp data points to analyze past weather patterns. What was happening in the past? What was the type of weather at the particular month or the particular day in the past, and what is likely to happen in the future, in the coming days or in the coming years, and make predictions about the future weather conditions. Databases like InfluxDB and OpenTSDB are based on time series data model. Next is multimodal data model. This data model combines multiple data models within a single database system, providing flexibility. This data model can handle various types of data simultaneously. Data can consist of various types of formats, whether it is documents, graphs, key value pairs, or other data types. A multimodal database can accommodate them all. That is, it can store, it can retrieve all these types of data, making it versatile and adaptable to complex data scenarios. That is, if an organization is wants to store or wants to retrieve different types of data, then it can make use of the multimodal data model. ArangoDB and CupDB are examples of databases that are based on multi-model data model. Hierarchical model. This model organizes the data in a tree-like structure where each record has a parent-child relationship. This model was commonly used in early database systems, that is, it was used in the past, such as the information management system by IBM. This data model has limitations in handling complex data relationships and evolving data schemas, which led to the development of more flexible data models like relational data model and NoSQL data models. That is, this data model has been superseded by the relational data model and NoSQL data models. Now the next is network data model. This data model is used to represent complex data relationships by organizing data into nodes and links. Unlike hierarchical model, it allows for many-to-many relationships. In this model, records are connected in a network-like structure where each record can have multiple parent and child records, fostering more flexible data relationships. This model was popular during the 1960s and 1970s. It has been largely superseded by the relational model. In other words, we can say that hierarchical model and network model stand superseded by the latest data models which are have come into existence or are still evolving. These are the just some common or some main types of data models that have been developed. Each model has its own strengths, its own weaknesses. The choice of the particular model by a specific organization depends on various types of factors such as data complexity, that is the nature of the data which the organization wants to store, scalability requirements, performance needs, and the nature of application. In some cases, hybrid approaches or NoSQL databases may be used to combine the benefits of multiple data models within a single system. It is essential to carefully evaluate your project's requirements before selecting a data model and database technology. That is, we if we are having an organization, we will have to take into consideration various aspects such as what is the cost involved, whether we are having the skills to operate the particular type of data model, where what type of services are provided by the vendors, what is the price if we make use of the particular data model, and many other factors. What type of data we want to store, what our performance needs, whether we want a, our needs will be scalable, that is, whether the data is likely to increase sufficiently in future. We will have to keep in mind various aspects. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.